Earth's history in geologic timescale.
Oh, hello there. Greetings, folks. We are here to discuss about Earth history. So, to begin with, why do we need to study the past? Because the key to understand the present is to study the past.
The early history. In ancient Greece, Aristotle observed that fossils of seashells in rocks resembled those found in beaches. He inferred that the fossils in rocks were formed by living animals, and he reasoned that the positions of land and sea had changed over long periods of time. Leonardo da Vinci concurred with Aristotle's interpretation that fossils represented the remains of ancient life. Siena, and the 13th century Dominican bishop Albertus Magnus extended Aristotle's explanation into a theory of petrifying fluid. Avicenna also first proposed one of the principles underlying geologic timescales, the law of superposition of strata, while discussing the origins of mountains in the Book of Healing. The Chinese naturalist Xin Ku also recognized the concept of deep time.
What is geologic timescale? It is a system of chronological dating that relates geological strata to time and is used by geologists, paleontologists, and other earth scientists to describe the timing and relationships of events that have occurred during Earth's history, or it is the calendar of events in the Earth's history. It is the geologic and climatic events.
The formulation of geologic timescale. The first serious attempts to formulate a geologic timescale that could be applied anywhere on Earth were made in the late 18th century. The most influential of these early attempts divided the rocks of Earth's crust into four types: primary, secondary, tertiary, and quaternary. Each type of rock, according to the theory, formed during a specific period in Earth history. It was thus possible to speak of a tertiary period as well as of tertiary rocks. Indeed, tertiary remained in use as the name of a geological period well into the 20th century, and quaternary remains in formal use as the name of the current period. The identification of strata by the fossils they contain, pioneered by William Smith, Georges Cuvier, John D. O'Malley de Halloy, and Alexander Brongniart in the early 19th century, enabled geologists to divide Earth history more precisely. It also enabled them to correlate strata across national or even continental boundaries. If two strata, however distant in space or different in composition, contained the same fossils, chances were good that they had been laid down at the same time. Detailed studies between 1820 and 1850 of the strata and fossils of Europe produced the sequence of geological periods still used today.
Timescale is divided into three units, which are the aeon, era, and period.
This is the aeons of geological timescale. Aeon, the largest time unit in the geologic timescale, next in order of magnitude above era. Era, a major division on the geologic calendar, still divided into shorter units called periods. Period, the basic unit of the geologic calendar that is the subdivision of an era, can still be divided into smaller units called epochs. Epoch, a unit of the geologic calendar that is a subdivision of a period.
Circumbrian time, Hadean Aeon, from the word Hades, which means hell. This is when Earth was active in volcanic activities and was constantly visited by meteorites. Archean Aeon. This lasted for about 1.3 billion years. The Earth's time was warm, still covered in water, the start of warming at continents, the start of multicellular organisms. Protozoic Aeon. lasted for about 1.9 billion years. Proterozoic means earlier life, and animals have started occurred current Aeon. Paleozoic era. In this era, fishes, insects, reptiles, mountains, and plants have started showing. This is also the start of theory of the supercontinent, are also known as a Pangaea. Mesozoic era. This is known as the age of dinosaurs. Also, the Pangaea was also believed to be separate in this time. Cenozoic era. This is the start of mammals and the evolution of humans, the adaptation and evolution of plants, animals, and the start of movement in mountains.
Thank you for watching.